Okay. So this is chapter 4.2 and 4.3, describing energy and conservation of energy. So in this class, we will know what is a kinetic energy, طاقة الحركة, and what is a potential energy, طاقة الوضع, and how to calculate both of them. Especially for the potential energy, we will focus on the gravitational potential energy, and at the end of the chapter, we will study conservation of energy and the power. Okay? So starting with what is energy? Energy is the ability to do work. The ability to do work. As we discussed last time, we said if you have a box and somebody will try to push this box, so he applies a force on the box, causing the box to move a distance d. So causing the box to move with your force is you do work. And this work, it gives energy to the system or here to the box. So when you do work or when work is done on a certain object, energy transferred to the object. Energy transferred to this object. And sometimes energy is transferred out of the object. You might transfer the energy out of the object. Like what? Like when we have friction. If we have friction, we said friction is an opposing force, resistance. So the friction, it takes energy out of the system, or it wastes the energy of the system. Okay? So energy is able to do work or to cause a change. When the work is done, energy is transferred to or from the object. Okay? The unit of energy is the same unit as the work. We said what is the unit of work? Newton meter, which is equivalent to the joule. So the joule is the unit of energy. This is the international system unit. There are different forms of energy. Mechanical energy. This is the most important, and we will focus on the mechanical energy in physics. The mechanical energy has different forms. It might be gravitational energy, it might be kinetic energy, some kind of potential energy. These are mechanical energy. Thermal energy, like when you heat up something. This heat is thermal energy. The nuclear energy, energy in the nuclei of the atoms and weight of the rod. Okay, there is energy in the nucleus by using the fission or the fusion, الانشطار والاندماج. Okay, these reactions will produce nuclear energy, and we can use it to convert it into thermal energy and then convert it into electricity. Okay, the chemical energy, the energy saved in some chemical compounds or some organic materials. Like if you have a piece of wood, okay, and when you burn it, if you burn it, okay, it will produce thermal energy. That means it has some energy before. This energy is called chemical energy. Like the fossil fuels. The fossil fuels like the oil, the petrol, the coal, the fahm, the gasoline or all of these fragments. Okay, these are chemical energy resources. The electromagnetic energy, like the sun. The sun gives us light. Light is electromagnetic. Okay, the microwave that you might use at home, the microwave, it has a source of electromagnetic wave, which is the microwave. If you put a cup of water inside the microwave for 1 minute, it heats the water up. So the electromagnetic energy changes into thermal energy. Okay. So these are like the chemical, the electrical, nuclear, or radiant. Okay. These are the major forms of energy in our life. Let's start with the kinetic energy. Kinetic energy is the energy due to motion. If there is a motion, so there is kinetic energy. If the object is at rest, so there is no kinetic energy. The kinetic energy, طاقة الحركة, depends on two factors. The mass of the object and the speed of the object. And here I say speed, not velocity. Because energy is a scalar quantity. Energy in general, it's a scalar quantity. It's not a vector. And also the work that we have studied last time, it's a scalar quantity. It's not a vector. Okay, guys? So work and energy are scalar quantities. قيم قياسية. So the energy or the kinetic energy depends on the mass and the speed v. The kinetic energy simply equals half times mass times speed square, half mv square. To increase this energy, you increase the mass or you increase the speed. For example, if two persons having masses 70 kilogram and 80 kilogram, and they are racing at the same speed, they have the same speed. So who will have more kinetic energy? Of course, the one with bigger mass. Okay, the one with bigger mass will have more kinetic energy as they have the same speed. Okay, 1,000 kilogram car is moving with a speed 25 meter per second. What will happen to its kinetic energy? What will happen to its kinetic energy? What will happen to its kinetic energy if the speed increases to 50 meter per second? So you double the speed here. It was 25, it becomes 50. So if you know the answer, you might write it in the chat. So you double the speed. The speed becomes doubled. So the kinetic energy will be 4 times. That's right. 4 times. Why? Because I have the speed square. So 2v square equals 2 times v, so equals 4, sorry, 4 times v square. So this will increase the kinetic energy 4 times. Like for example, if the speed increases 3 times, so the kinetic energy will increase 9 times, and so on. Okay? So this is the relation between speed and kinetic energy. Potential energy, طاقة الوضع, potential energy. It's an energy stored in the object. Stored, تخزن. So it's an energy stored when the object moves against a certain force. So this energy is stored in the object. We cannot see it but by our eyes, but we can see the results of this energy, or we can see when this energy changes to something else. Let's see. Elastic, the first kind is elastic potential energy. Like what? Like if we have a spring, and you attach a ball to the spring. Let's say you will pull the spring, so you will stretch the spring. You will pull the ball, so the string will be stretched. When you stretch the spring, you save energy inside it. You save energy inside this spring. This energy, we call it potential energy or elastic potential energy. Elastic means marine, elastic. How can we see the result of this energy? Once you release, you hold the ball. Once you release the ball, what will happen to the ball? The ball starts to move back. So starts to move means it will have a speed. So it will have kinetic energy. So this potential energy will change into kinetic energy once you release the ball and let it to move or leave it to move. The ball will swing back and forth, okay, for some time. So you save energy, which is potential energy. If you want to see the result, you can release the object to move. It will convert into kinetic energy. In the bow, if you have a bow, house, like this one, and if you have an arrow, when you pull the arrow back, when you pull it back, you will stretch the string. There is a string here that you will stretch it. When you stretch it, you save energy inside it. You save energy inside the string. This energy is potential energy. Once you release the bow, the string will push the bow with a speed v whatever, 20 meters per second, for example. Okay, that means the energy that you save, this potential energy, changes back into kinetic energy. Okay. Potential energy also, you can see it in electricity, the electrical potential energy. This 220 volt, or sometimes in some places 110 volts. That's called potential. We call it potential. Okay, between the two wires, one of them for like a certain time, at a certain time, one of them becomes positive and the other becomes zero or negative. Okay, so because of the change between the charges, there should be a potential between the two wires. It's a kind of potential energy. Okay, the chemical potential energy, the stored energy inside some compounds like the methane, or like the piece of wood that we talk about, or the oil or the coal. Okay, they save energy inside them, so it's kind of potential energy, but in this case it's chemical potential energy. Okay, if you want to release it, you need to burn the methane plus oxygen. It will give you thermal energy. Okay, if you want to see the effect of electricity, you just plug in your device, your television, washing machine, whatever device you have. This potential energy changes into something else. In the washing machine, it changes into kinetic energy when it works. In the microwave, you can change it into electromagnetic energy. In the stove, you can change it into thermal energy if it's working by electricity, for example. In the television, you change it into light, and so on, which is radiant energy. We will focus in the potential energy at the gravitational potential energy. What is the gravitational potential energy? When you raise an object above the ground, if you have an object on the ground and you hold it and then you raise it upward, so you move against gravity. You move the object against gravity. So you store energy, you store some kind of energy inside this object, which is a potential energy. We have discussed the work that the object or the work that you do on the object when you raise it up against gravity. Do you remember what is it? When you move a certain object that has a mass m, a certain height h.
MGH.
It says here, or that's right, mgh. This work is stored inside the object as potential energy. It's stored inside the object at potential energy. As potential. So the potential energy equals mgh. The potential energy equals mgh. This is the gravitational potential energy. M is the mass, h is the height of the object above the ground, for example. Okay? If you want to increase it, you can increase the mass or increase the height. The unit. What is the unit of energy? Joule. The unit of energy is joule. Okay? Radiant energy, it's like the light or like the infrared or like the microwave. We talked about this one. Conservation of energy. We have talked about the conservation of momentum before, right? We have talked about it before. But today we are going to talk about the conservation of energy. What is it? Energy cannot be created or destroyed. You cannot create energy and you cannot destroy energy. So wasting energy is not you destroy it, but you just convert the energy from one form to another form. That's what we are allowed to do. Okay, the only one who can create or destroy energy, only Allah can do that. But we only are allowed to change the energy from one form to another form, not more than that. Okay, but the total amount of energy remains conserved. This is known as the law of conservation of energy. Like in this picture, when you plug in the bulb, what is the energy of the electricity? We call it potential energy. The electrical energy is some kind of potential energy. You change it into what? You change it by the bulb. You change it to what, guys? Light. Mainly light. Mainly, like maybe 80% light. But there are some waste. Okay, 20% is lost as heat. Okay, 20% is lost because like we don't like, mainly we use the bulb as a source of light. We don't use it as a source of heat. If you use it as a source of heat, that's something else. But we are talking about the bulb as a source of light. So 80% actually it's not very bad. Okay, when you reach to 80%, or in some cases 90%, okay, that's very good. Okay, in the old days, maybe the bulb has efficiency 40% or maybe less. Most of the energy, it's wasted as heat. But now we have the LEDs, the LED light. It has very high efficiency, very high efficiency. So we convert most of the potential energy into light, and a few amount or a few percentage is wasted as heat. Okay, can anybody give me an example to the conversion of energy? Yes, Hussam?
In the car, the engine, the chemical energy to
chemical energy. So the chemical energy coming from the gasoline or coming from the solar, we change it in
mechanical energy.
Okay. Actually, the engine does not change the chemical into kinetic energy or directly, but when you burn the gasoline, you change the chemical energy into thermal energy. You change it first into thermal energy. This thermal energy will expand the gas, as we will discuss later in chapter 14 and 15. Okay. It will expand the gas, and this gas will push the pistons of the car. If you have four pistons or 6 or 8 pistons according to the car, and these pistons, they convert it into motion. So chemical changes into thermal, and then using the piston you will change it into kinetic energy, which is a motion. And this motion we can convert it back into different things. Using the dynamo in the car, you can change the kinetic energy into electricity again. Okay, if you want to, for example, charge the USB in the car or use the lights of the car. Okay, that's kind of electricity. You need it also to do what? To charge the battery of the car. You might use also, you change it into thermal energy for the AC, the air condition, okay, to absorb the heat and remove it out of the car. That's kind of thermal energy, okay. You might keep it as kinetic energy because you need the car to move actually, okay. Okay, what else? Sulaiman says the sonic energy. This is the energy of sound, the energy of sound. Okay, we can. That's right. So if you turn on the radio in the car, you change it into a sonic energy. Good. What about the fan? The fan changes electrical energy into kinetic energy using the motor, because the fan has a motor. The motor receives electricity, the potential electrical energy, and change it into kinetic energy. That's right. Okay. Let's take a final example. When we eat food, Hassan says, when we eat food, it looks like you are hungry now, Hassan. When we eat food, we transform the chemical energy, okay, into what? We transform the chemical energy of the food into heat, because we need to warm up our bodies. Okay, we burn it actually in our body. We burn the food, like when you burn a piece of wood. The same exactly. You use the oxygen, you inhale the oxygen, and you burn it. Of course, there is no fire, but you burn it. So you convert it into thermal energy to warm up your body, and you convert it into motion because you need to move and your heart needs to beat and so on. Okay? Okay, that's good. Energy conservation. Energy conservation. If you have a certain object at a certain height h, okay, and you hold the object in your hand. So now the object has potential energy. What is the potential energy of the object? mgh. mgh. What about the speed of the object? 0. It has 0 speed. So the kinetic energy of the object now is 0. What about the total energy? Total energy here, we call it the mechanical energy. What is the mechanical energy? Mechanical energy is potential energy plus kinetic energy. I need to remember this equation. Mechanical energy, ME, equals potential energy, PE, plus kinetic energy, KE. Okay? So the mechanical energy is the sum of potential energy plus kinetic energy. In this example, he called it TE, total energy. It doesn't matter, mechanical or total. So the mechanical energy here is only potential, which is mgh. mgh. Once you release the object, if you release it to move, what will happen? As we know, this is called free fall. So the object starts to move down under the gravity. So the speed will increase. The speed will increase. While the height will decrease. So here we are talking about two things, the potential and the kinetic. The potential energy will what? Decrease. And the kinetic energy will increase. Why? Because the height decreases and the speed increases. Okay? So the potential energy will decrease while the kinetic energy will increase. If you add this one plus this one, the potential plus kinetic, that's called mechanical energy. The mechanical energy does not change. Does not change. If we, of course, if we assume there is no friction of air, the air resistance and all of this stuff, so the mechanical energy is conserved. The mechanical energy is conserved. Conserved means it stays constant. How does it stay constant? How is it stay constant if the potential energy decrease and the kinetic energy increase? This one decreases and the other one increases, but if you add this one plus the other one, it gives you a constant number. Until you reach where? To the bottom here. One moment before the object touches the ground, the height of the object becomes 0, so the potential energy becomes 0. And its speed becomes maximum speed, so its energy becomes maximum kinetic energy. So the kinetic energy here equals FmV maximum square. What about the total energy? Total energy, it's only kinetic. Total energy only kinetic, half mv maximum square. So again, at the beginning, the mechanical energy is mgh only. mgh only. Then somewhere in the middle here, it's both of them, mechanical plus potential plus kinetic. And at the end, all of the potential has changed into kinetic energy. So at the end, it turns into kinetic energy. Conservation of energy says what? Mechanical energy does not change. So the mechanical energy at the beginning, let's say this is number 1, equals the mechanical energy at the end, this is number 2. Of course, equals to any point. Any point in the middle is the same. So the mechanical energy at the beginning is mgh. the mechanical energy at the end is half mv maximum square. It's a good equation. So in the problem, I will tell you what. If the object has a certain height, 10 meters, 10 meters, find the maximum speed of the object. Find the maximum speed of the object. And I will not give you the mass because you don't need the mass. What? Because you will remove this mass with this mass. So you will say 9.8 times height, which is 10 meter, equals half times v maximum square. And so you can get the speed. It will be 2 times g times h under the root. Gives you around what? If you have a calculator, around 14, I think. 14 meter per second. Okay. So this is the maximum.
Professor, repeat it, please.
Okay, we will do it. Here I have the mechanical energy at the beginning equals the mechanical energy at the end. The mechanical energy at the beginning is only potential, mgh. And the mechanical energy at the end is only kinetic, because you waste or you converted all the potential. So you only have kinetic. So it's half mv square. So it's a relation between, if we remove the mass from here and from the other side, it's a relation between the height and the speed. The height and the speed. Or the height and the final speed. I'm talking now about the final speed. Okay. So G is 9.8. 9.8. Sorry, here is H. Times the height, which is 10 meter. Here in my problem, it's 10 meter. Equals half times V maximum square, which is the speed at the end. You will substitute and find V. The V becomes 14 meter per second.
Okay, thank you very much.
Okay.
But doctor, in the end, it will be the height will be 0, right?
Yes, the height will be 0 at the end. Potential energy is 0 at
But
the end. There is
why
no.
You put it 10?
Okay, you don't understand. MGH, this is the potential energy at position number 1. This is position number 1 before it falls down. It has a height. Okay. And half mv square, it's at the end, position number 2. So I equate mgh in position 1 to half mv square in position 2. Okay?
I got it.
Okay. In the middle, let's say you are exactly in the middle. What will happen in the middle? If the object is at a certain height, h over 2. This is h over 2 and this is h over 2. The mechanical energy here is potential energy plus kinetic, both of them. And the potential energy equals the kinetic energy. In the middle, the potential energy equals the kinetic energy. Turkey here is the speed is 7. No, it's not. It's not. Let's see why. The potential energy, let's say this is position 3, for example. The potential energy 3 equals the kinetic energy 3. The speed now is called V3. And the height h3 is h over 2. Let's substitute and see. Let's substitute. Potential energy is m g h. What is the height in position 3? The height is h over 2 equals. Let me erase this stuff. Equals the kinetic energy in the middle. I assume that the speed here is v3, so it's half times m times v3 square. Remove the mass with mass. Remove the half with half. Okay, so GH equals V3 square. So can you calculate V3, guys? Root of 9.8 times H is 10. What's the answer? What's the answer? Almost, that's 7 root 2. 7 root, which is almost what? 9.89 meter per second. So it's not 7. It's not 7. Okay, so take care that the kinetic energy in the middle is half the kinetic energy. But take care that the kinetic energy equals half mv square. So the speed will be root 2. Root 2. Take care of the root 2. Okay. Here in this one, you can see the roller coaster, okay, moving up and down. If we neglect friction, and air resistance, so the mechanical energy is conserved. Mechanical energy is constant. What is the mechanical energy? Potential energy plus kinetic energy. When the object is at the top, this is the maximum potential. Look, now maximum potential. Okay, and lowest kinetic. The lowest kinetic at the top. And when the object moves down here at this point, or when it moves to this point, you will find it the lowest potential. Okay, the lowest potential. So let's look here at point B. You will find this is maximum kinetic and lowest potential. So when the object moves up, this will increase potential, decreases and decrease the kinetic. When it moves down, this will increase the kinetic and decrease the potential. But at any time, if you add this one plus this one, it gives you constant. So if we take 2 points, A and B, the kinetic plus potential at A equals the kinetic plus potential at B. Okay, which is the mechanical energy. Okay, guys. In the projectile motion, you hit the ball with a bat, for example. So you give it a speed v initial, and let's say this will happen at a height from the ground h initial. So now this projectile, this ball has a mechanical energy equals potential plus kinetic. Potential is mg h initial plus kinetic half mv initial square. The object moves up until it reaches from point A to point B. At point B, the height increases, so the potential increases. And at the maximum, it's the maximum potential. Because this is the maximum height, so this is the maximum potential. What will happen to the speed at this point? What happened to the speed? The speed now becomes minimum. It's not zero, but becomes minimum. This is the minimum speed. So this is also the minimum kinetic energy. But if you add kinetic energy, this kinetic energy, plus this potential energy, it gives you the mechanical energy. The mechanical energy is constant. The mechanical energy at the beginning equals the mechanical energy at point B. Of course, if we consider no air resistance and friction and this stuff, okay, the mechanical energy is conserved. So potential plus kinetic at A equals potential plus kinetic at B. If you go to C, the point C, of course, almost there is no height. The height almost is zero. So we can consider the potential energy to become zero or very, very small amount. Okay. And the kinetic energy becomes maximum. Okay. If you add this one plus this one, it gives you the mechanical energy at point C It's the same as the mechanical energy at A, the same as the mechanical energy at B. So the mechanical energy does not change, but the change is in potential and the kinetic. If one of them increases, the other must decrease to save the total amount balanced or to save it conserved. Okay, guys? Understand this one? Some people might think that the speed at the top point here is 0. No, the speed is speed. Vx, if you remember, at any point in the projectile, at any point there are two components of the speed. Two components of the speed. Let me remind you. There is horizontal component and vertical component. The horizontal component is constant. Vx, 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 Vx does not change at all. Vx does not change at all. But Vy, the vertical component decreases until you reach to the top. The Vy becomes 0. So this is the 0 part, not the whole speed, but only the vertical component of the speed. And when you move down, the vertical speed increases again. The vertical speed increases again. Okay, until it becomes maximum vertical speed at the bottom here. Just before it hits the ground, this is the maximum vertical speed. What if I ask you at point C? What is the total speed at point C? Total speed equals what? Do you know, guys? Does anybody know what is the total speed at point C? It's the maximum, but how can I calculate it? I have two components, Vx and Vy. How can you calculate the speed Vc, the speed itself, Vc? That's right, Hassan. Excellent. From Pythagoras rule, Vx square plus Vy square. At any time on the projectile, you can do that. To get the total speed, you just use Pythagoras rule. Okay.
But in this example, they don't give us the components of the V, so we can't calculate it.
I mean, if it's given, if it is given,
okay.
and you
I mean, as a general rule, yeah.
No. But
Sorry.
here, in the energy, usually we use the speed, the whole speed. We don't use Fx and Fy, but we use the total speed. Okay. So in the kinetic energy, we use total speed. We don't use X or Y. For the swing, or for the pendulum, al-urjuha. For the pendulum or the swing, they are exactly the same. If we neglect friction and we neglect air resistance, so during the stationary position, which is in the middle here, in the center, the object reaches its lowest point, lowest height. The lowest height, let's say the height here is 0. So at this point, let's call it point 1. Here, point 1. The height is 0, so the potential energy is 0. The potential energy is 0. Okay? When you move the object, when the object swings and reaches to the maximum height, h, or here the maximum height, h, should be, let's take it between those two positions, h. In the maximum height, you have maximum potential. So the potential energy, mgh, is the maximum. But on the other side, what is the speed at this moment? The speed is 0. The speed at this point is 0. So at the maximum height, the pendulum or the swing reaches to 0. It's an instantaneous speed, by the way. Okay, it's like one moment. The speed becomes 0. So the kinetic energy becomes 0. Kinetic energy now is 0. Okay? When the object swings back, when it moves back, the speed increases until at the bottom it will have the maximum speed. And the maximum speed leads to maximum kinetic energy. So at the bottom here, the kinetic energy, here he write it EK and EP. I used to write it KE and PE. It doesn't matter, they are the same. So the kinetic energy here is half times m times v square. And the speed here is maximum speed. During this point, let's call it point, let me call it point 1 and point 2. In point 2 here, this is maximum speed and maximum kinetic energy and zero potential energy. On the other side, on position 1, this is maximum height. So this is maximum potential energy and zero kinetic energy. But there is something constant here. What is it? Mechanical energy. Mechanical energy is this one plus this one, or this one plus this one. Mechanical energy is conserved. Mechanical energy is conserved. So mechanical energy at 1 equals mechanical energy at 2. What is the mechanical energy at the first point? It's only potential, mgh. What is the mechanical energy in the middle in point number 2? It's the maximum. With kinetic only, have mv maximum square. Similar to the gravity, the motion under gravity, okay? So we can use this equation. I will give you the height, and I will ask you what is the maximum speed. Or I will give you the maximum speed, and I will ask you what is the maximum height the pendulum can reach to. Okay? So I give you the height and ask for the speed, or I give you the speed and ask for the height. What if I told you in the middle exactly, at a height h over 2. So you will do the same exactly like what we did here. Okay? In the middle exactly, the potential energy equals the kinetic energy. Okay, so we call it point number 3. So mgh3 equals half mv3 square. The potential energy here equals the kinetic energy at this point. Okay.
Divide the height by 2, right?
Yes, the height here, if you are at the middle exactly, the height h3 equals h over 2. You will remove this half with this half, this mass with this mass. 9.8 times h equals v3 square, so you can find v3. Okay, the root of this number. Again, the condition here is we have to neglect air resistance and any kind of frictions to keep it conserved. There is a website here.
Doctor.
Yes.
So you mean when we neglect air resistance and any type of friction, the swing will just keep swinging and swinging and swinging and it will not stop?
Forever. Yes.
Okay.
And there's a toy that you might buy from some stores. I don't know where can I find it here, but it has like a ball. Okay. And they evacuate the air from inside. Okay. Like it's a glass box and it has a ball tied by a rope and they evacuate it. They keep it under vacuum. So they suck the air from inside. Okay, and they like give it the best material, so they will decrease the friction, and when you swing it, it keeps swinging for hours, okay, without any source of energy. Okay, you just start to swing it, it will swing for a very, very long time. Okay, in this case we can consider the mechanical energy is conserved, because there is no air resistance and there is no friction, almost.
May I ask a question?
But just let me tell you about this website. When you click on this website, it will take you to this one here. It has the motion of pendulum, so you can observe the motion of the pendulum I want you to look at the pendulum at the lowest point. At the lowest point, you will find the kinetic energy to be maximum. Okay, so the kinetic energy here is maximum. And when it reaches to this point at the edge, you will find the potential energy is maximum. Okay, so you might need to look at the motion of the pendulum, and also you need to look at the value of kinetic energy and the value of potential energy. If you add the potential energy plus the kinetic energy at any time, they give you the mechanical energy, which is conserved. Okay, so at the middle, at this point here, let's look the values of the kinetic and potential. What happened at this point? What do you think? They are the same. They are equal. At this point, at the beginning, you will find all the energy is, all the energy is potential. All the energy here is potential. And at the bottom here, all the energy is kinetic. Okay. So next time, inshallah, we will discuss the power and some other issues and solve problems. If you have questions, so please ask.